In this video, we will look at just a couple more examples of polynomial long division, just for anybody who needs a little more reassurance about the procedure for this. So, what are the quotient remainder when the quartic polynomial 2x to the fourth minus x cubed minus 2 is divided by the quadratic polynomial 2x squared plus x plus 1? So, I'm going to start with 2x squared plus x plus 1 divided by, and I always like to spread it out a little bit, just so I have enough room, 2x to the fourth minus x cubed. Now, I notice I'm missing a couple terms here, so it'd be like missing digits. So I need to include digits of 0 when I write numbers, so I need to include terms of 0 when I write this. So I'm going to have a minus 0 or a plus 0x squared plus 0x minus 2. I need to remember to include zeros for missing terms. Oh, I think I wrote that a little high on my screen, so I'm just going to take that, pull it down a little bit. All right, so now what we are looking to do is, first and foremost, be able to perform a subtraction in such a way that when I subtract, whatever I subtract here will give me a 0. That's our whole idea about working down and across. So I want to have a 0 there. The question is, how do I get that? Well, I look at my divisor. I look in that divisor there, and the question becomes, what am I going to multiply that by so that my subtraction gives me 0? Well, it's a 2x squared. I know that, in my head, I want this, maybe I could use dash. I want this to be a 2x to the fourth. So what am I going to multiply 2x squared by to get a 2x to the fourth? Well, that's going to be an x squared. And I am going to write that, because we want to align everything correctly. I'm going to write this over here. I'm going to simply need an x squared. Now, when I take my x squared and multiply that by my divisor, 2x squared plus x plus 1, I get 2x to the fourth plus x cubed plus x squared. Now remember, I'm going to subtract, and as I spoke about in the last video, I'm going to put that in parentheses so that I remember to distribute the negative. So I have 2x to the fourth minus 2x to the fourth. That will give me a 0 that I'm looking for. Then I will continue, and I will have negative x cubed minus x cubed. That's actually going to give me a 0 as well. I'll put a plus there. I'll probably erase those in a minute anyways. Then I'll have 0x squared minus x squared, and that will give me a negative x squared. I don't believe that I need these, so I can erase those. So now my focus shifts. I'm no longer going to be focusing here. I'm going to focus here and say, how can I get rid of this negative x squared? Well, since we are going to have a subtraction, what am I going to want to subtract there? Well, I'm going to want to subtract a negative x squared, so that when I have x squared minus negative x squared, I will get my 0. Now the next question, how do I get the negative x squared here? Multiply through here. What am I going to put in that position? Well, actually, it looks like I'm going to need a fraction. So here I'm going to have a minus 1/2 x, or not even a minus 1/2 x. It looks like I'm just going to need a negative 1/2, because that would give me too high of a degree. So I am going to multiply by, let me print this here, minus 1/2. When I take my, I don't want to take that, you stay there, negative 1/2 multiplied by my divisor, I am going to get, let's see, negative 1/2 times 2 is negative 1. X squared is going to be x squared. That's good. Then I need to do negative 1/2 times x, which would be negative 1/2 x. And negative 1/2 times 1 would be minus 1/2. I need to drop some terms down here. I'm going to drop those two terms down so that I can work with them. Plus 0x and a minus 2. So I now have negative x squared minus negative x squared, that would be 0. 0x minus negative a half x, and when you subtract the negative, it's a positive, so 1/2 x. And then, oops, grab the wrong thing there. There we go. Negative 2 minus negative a half, which is really plus a half. So that would be, let's see, negative 2 plus a half would be negative 1/2, but I'm going to write that at negative 3/2. I'm all the way over. I don't have anywhere else to go. I don't have anywhere else to go. My remainder has a degree less than the degree of my divisor, so it's smaller, you know. So I've got nothing left to do. So in this particular case, my quotient is going to be x squared minus a half, and my remainder is going to be 1/2 x minus 3/2. So looking at a couple other things there where we had to do some term skipping and making things, make sure things line up correctly. And that's what we have to do with these polynomials. We have to just make sure that the first term always disappears when we perform the subtraction. Another subtraction, another division problem here, worded a little differently. Is x minus 2 a factor of the cubic function given by f of x? So really we're asking, is the remainder 0? And the only way I know if the remainder is 0 is if I perform the division. So in this particular case, I've got this linear divisor, x minus 2, and I've got this long cubic, x cubed minus 3x squared plus x plus 5. In this particular case, I have no missing terms. I've got my cubic, my quadratic, my linear, and my constant term, so I don't need any zeros put back in there. I'm going to go through this one a little more quickly. Hopefully we're getting the hang of it. I need to make sure that when I do my division, when I do my subtraction, I get my zeros. So what am I going to multiply by to get an x cubed? I'll grab my highlighter here. You know, I'm going to want an x cubed there because x cubed minus x cubed would give me 0. But to do that, I need to multiply the x by an x squared. So I'm going to line up my values. So I'll have an x squared here. X squared times x is x cubed, and then x squared times negative 2 is minus 2x squared. I'm going to close that. I'm going to subtract. X cubed minus x cubed is 0. Then I'll have negative 3x squared minus negative 2x squared. And when I do that, that's really an addition of a negative x squared. Probably need to drop a term down here, so plus x. And once again, my focus changes. I'm no longer on my original polynomial. I'm working here, and I need to say to myself, when I subtract, I need this piece of the subtraction, negative x squared minus something, to be 0. Well, that only works if this is a negative x squared. That's what would give me 0. How am I going to get a negative x squared? Here, based on this divisor. Well, it looks like up here, I'm going to need a negative x. Negative x times x is negative x squared. And then negative x times negative 2 is plus 2x. Perform my subtraction. Negative x squared minus negative x squared is 0. And then x minus 2x is negative x. Looks like I have one more step, a plus 5. I'm going to want to have my subtraction. My focus is here. How am I going to get a 0? Well, this is going to need to be a negative x. Question is, how do I get this to be a negative x? I get that by having a negative 1 up in my quotient line. Negative 1 times x is now negative x. And negative 1 times negative 2 is positive 2. This subtraction is 0. And then 5 minus 2 is going to be 3. Just finish this off. When I have this, I have a quotient of x squared minus x minus 1 and a remainder of 3. That's not quite the question. The question was, is x minus 2 a factor? We could say no, x minus 2 is not a factor of x. We don't have a remainder of 0, doesn't divide in evenly, not a factor. Okay, just a couple more examples to help you look at them, play with them, gain confidence in the procedure. And I'll see you guys in class.